Hello. Let's continue with the geometry side of exploring a potential candidate that would explain many of the things that Terrence McKenna described in relation to self-transforming elf machines. Okay, so uh, first, I've just watched a an interview with Dennis McKenna. I feel the need to sort of apologize. I think I've come across a little too confrontational, um, a little bit arrogant, and I apologize for coming across like that. Anyway, yes, I just watched an interview with him, recent. So he mentions things that are interesting. He too has picked up on the fact that there is a strong direct link between the events at La Chorrera, the events at La Chorrera and time wave zero. Okay, and that's fine. Terrence openly states that in The Invisible Landscape. There's nothing new there. What I'm trying to bring to the table is the fact that there are, in fact, a lot of links between time wave zero and self-transforming elf machines. All right, that's the bit I. So when you realize that time wave zero is incomplete because it's piggybacking on the I Ching, which itself is not incomplete, but it's piggybacking on information contained within the 24 cell, right? It's that simple. Uh, yeah, so if we now see that that's why I drew this triad of events, the experiment at La Chorrera, Time Wave Zero, and the self-transforming elf machines. All three are connected, obviously. All right. My only entertainment of an idea is, from my perspective, is how is the third person connected to this exactly? How is this? My hinting is that there is something. I don't know. I think we're on the edge of something. We're going to discover something here. There's something important. All right. Yes. So that's it. That's cleared up. I have got it established that we are now going to explore the link between the time wave zero and the self-transforming elf machine. First, we need to finish off with some geometry, and then I can start to show you that connection between Terrence's descriptions and uh, the thing I found, the 24 cell. It's how I've used the 24 cell. That's really the key. All right. So let's just recap. We have this object, that's the 24 cell in its 24 cell form. All right. Um, we then have this noisy bugger. I'm sorry about that. We have it in its hinged form, hinged dissection. Yes. Now, all along, all that is it's not easy to show, but it's really just a spiral, right? You've got a spiral that's coming in this way. The other side of it's white, and this is the other side that I'm trying to show that's you don't see when it's in that other form. But it's all just this, and all we're doing is folding this up into origami like things and continuing that process. It's when one sharpens a pencil, um, that the shaving, how it comes off, that's really what this is. That's a good way of describing it. It's like shaving off the pencil, old school style with a pencil sharpener. Yeah, that's a good way to visualize this surface that sort of coils up. That surface crumples down into the hinged form, and then it finally wraps into a particular loop form to be the 24 cell as the frame, right? Just some other ways to help visualize it. Oh, one other thing, that's right. I showed you the color form, and I can't express it enough. What I'm showing you here, this is the full one with the north and the south pole. It's seen better days, I'm sorry. Right, that's what I mean by flooding it with a constant spectrum. I've used a spectrum up and a spectrum down, so 12 different colors into 24 cells, that kind of thing. But yes, now this object, that's one layer, right? That's what I'm trying to get at. Terrence says it's on several layers, right? But I'm saying there's 383 more layers to go deep in or out, whichever way you want to think of it. It doesn't really matter, but you need to think of it like a vinyl record, you know, so that each track is one line, and then the next track parallel to it is another directional line, and each one is a unique line out of those 384. So it is, straight away, it is an interesting connection that 384 being the number required to describe this object in a very deep way, really get your handle on what it is and what it's doing and how it has been constructed. Yes. Okay. So yes, that's one layer. Just remember that. Again, maybe just to make it clearer, that spiral that I was showing you, this, right? It's really made up of 24 of those, all right? And imagine the next one and the next one and the next one, or back, whichever way, right? Coming this way into, all right. And I said we want to look at that little TP-like structure, and that's the TP-like structure. If you see what I mean. That's obviously the floor. Just so you understand how you move from that spiral surface into this little mountain thing, TP mountain, and then you finally, by putting a whole lot of these together, obviously you can see how one sits in, like a docking station almost. All right. Now 384. So what exactly is 384 about this object? All right. Again, we're not going to spend too much time with this mathematics, but essentially, let's say I'm holding a cube in front of me. I'm asked, how many ways can I rotate it such that it looks the same, right? So it's these simple types of questions that you ask. That question is obviously asked of every single polyhedra, you know. But in this case, the answer was 384 for a particular type of question, all right? So directed, how many, so they're kind of like orbits. You either keep this still and you fly around it, right? Or you keep yourself still and you turn, rotate, up, down, right? So it depends on the order at which you have done these series of symmetrical steps, you know. I know it starts to get a bit, it's some decent maths in there. All right. Now, I also pointed out earlier that I'd put letters on each one of the cells. So cell 1, I put an A. Cell 2, I put a B, and so on. Okay. Now we want to go and look at these orbits, and we'll write them all out one by one. All right. Now, when I've got very complete orbits, meaning I just look. It doesn't really matter. The complete orbit, as in, I need to go through every single cell, right? And there's 24, which means to be doing the ultimate path around the object, you have gone through each one of the 24 cells, correct? Yes. Right. If you now look at every single type of orbit through the path, all the possible paths around the object that don't necessarily go through every single one of the 24 cells. So they may only go through 3 or 4 or 8 or 10 or 12 before they get back. So it's all these, if you want, boomerang paths. They go round, 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 come back. And then a bigger one goes further out but comes back. But they've got to come back. If they don't come back, we ain't counting them. Okay, so of these particular paths, there's 384 to describe this 24 cell. That's really handy. That's good to know. We have now established that the 384 of time wave 0 might actually be the 384 paths that we've just found in the self-transforming elf machine, right? I'm going to call the 24 cell from now on the self-transforming elf machine. Again, can you imagine this thing, which is 383 more levels deep? It's all computing, right? I don't know what it's computing, but it's in the thick of compute, right? Now imagine a cluster of them. Now, I don't know how big these things really are. I don't even know if they actually take up space in the 3D world. I'm not sure. But, yeah. All right, and to finally finish then, so what's puns? And I'm going to leave deja vu out of this episode, because then we're going to start to get into time travel. How are we going to do it? But the whole idea of these puns. Okay, now I'm just going to roll something up. I'm sorry, it's all backwards for you, because I'm doing this in reverse world. I found that 384 are just the peaks. They're the highest peaks. So they are the tip, right? And so they're important. Don't get me wrong. But really, the 384 are part of a larger group of 1,591. So when I say time wave 0 at its base unit is incomplete, it's because it's roughly a quarter of what it should be. Now, I'll try and give you an idea of how the successive runs of routes through cells, and you slowly build it up, and then you finally get to the maximums, and obviously you can see where the maximums are here, 1, 2, 3. Now I'm showing you about 40 of the first ones, but there's 1,591 of these particular paths. Each one is unique. You never cross paths. And here's your printed pun. This is the 24 cell. This is the self-transforming machine. Communicate. All right, that's enough. You get the idea. It's all here, exact, in the right order. That took me a long time. Again, I needed to use Mathematica from Wolfram to do it. I couldn't have. I got. I do my own order, but I needed to get each particular cycle through. Yeah, they call them cycles, because you're going from cell 1 to 2 to 3 to 4 to 1, right? And then you are a complete loop. So it's a cycle. Um, the technical term for the ones that are the maximum cycle, where they go through all 24, are called Hamiltonian cycles. If I'm thinking about this as graph theory, which has been extremely helpful to consider them, to consider the self-transforming machine elves in terms of graph theory, has been very helpful. Probably the most successful strategy for me forward that I found over the entire years. Um, Mind you, you cannot take the geometry away at the base. Without the geometry, I wouldn't find any of this half as interesting as I do. But yes, because geometry is my well, it's definitely a big passion of mine. Yes, yes. I just thought I'd show you one last couple, just to get that intensity of where you're. It's just a lot of information packed in there, and yeah, let's let's see where that goes. But yes, next I'll talk about deja vu. I need to show you some things.